Hello there, and welcome to the Whispering Science, your quiet corner for unraveling life's greatest mysteries, one gentle, thoughtful story at a time. As you settle in beneath the hush of night, let the outside world soften until it's little more than a whisper against your window, and let your mind wander with me into the cosmos. Tonight, we'll explore a question that has quietly occupied minds for generations. Does space ever end? Now, I do hope this isn't too interesting that it keeps you awake. But if it does, well, at least you'll have learned something fascinating about the universe, enough to let your imagination drift long after the lights are out. Before we begin, if you enjoy these slow science journeys, I'd be ever so grateful if you tapped the like button, subscribed, or even just left a comment telling me where in the world you're watching from and what time it is in your corner of the night. These small gestures help our little nighttime science circle grow and reach others seeking a peaceful path to knowledge. Let's begin by returning to the earliest spark of wonder, a memory so many of us share. Imagine yourself as a child, lying on a patch of grass or peering out a window, your gaze turned upward to the nighttime sky. The dark expanse above is speckled with stars, silent, twinkling, innumerable. Maybe you felt it then, that tingling question rising in your mind, as gentle as the night breeze. Does the blackness go on forever? Is there a wall somewhere, a place where the stars just stop, where the whole universe comes to a close? Or is it possible, in a way both wonderful and slightly unsettling, that space simply never ends? This kind of curiosity blends seamlessly into the nighttime moment, half dream, half question. Children especially know the feeling. Before anyone weaves in facts, current theories, or learned skepticism, there's a pure, almost magical kind of awe. You might have tried to imagine tracing a path outward, past the last star your eye could see. Would there be more and more stars, endlessly? Or would you find a boundary, like the walls of a room? Did the sky then, to you, feel like a ceiling? Or did it instead provoke a delicious kind of vertigo, that sense of dangling at the edge of a great unknown, too vast to wrap your imagination around? For countless generations, this natural sense of wonder has drawn people outside, heads tipped back, hearts beating a little faster beneath the blanket of stars. Some cultures read stories into the shapes of constellations, while others use the regularity of the heavens to predict seasons, time their crops, or navigate vast oceans. But underlying all those practical details was this haunting, peaceful question. Is there more sky beyond the sky we see? And, if so, how much more? Perhaps you remember, as a child, or even just last week, asking a grown-up if space ever ended. Maybe you received a gentle answer, or maybe someone said that it's a mystery, even to the cleverest scientists. In many ways, that is still true. But tonight, in our journey, we'll see just how much humanity has uncovered, and just how much our own childlike wonder continues to shape even the boldest scientific quests. This initial spark, this impulse to look up and ask big questions under a quiet sky, is truly universal. Whatever your age and wherever you are in the world, you hold in your mind the same deep awe that long ago guided ancient astronomers and modern physicists alike. The sky invites us not just to sleep beneath it, but to dream far beyond it, to pursue an answer, gentle and profound, to the question, does space ever end? As we let that wonder settle softly beside us like a favorite blanket, we prepare to follow its thread through centuries and light years, from ancient pondering to the frontiers of science. So, as your breath slows and your thoughts drift, hold on to that childhood sense of wonder. It is both a lullaby and a compass, guiding us calmly toward discovery as our journey into the cosmos gently continues. As we float further into our quiet journey tonight, let's look back in time to those who first tried to answer the question, does space ever end? Long before telescopes or satellites, before the gibbering hum of electricity or the quiet hiss of central heating, there were people just like you, curious, questioning, and wide-eyed, living beneath the same stars. Their views of the cosmos shaped not only their beliefs, but the very way they walked through their own lives. Ancient civilizations, separated by oceans and language and time, gazed up and formed their own models of the universe, each deeply tied to what they could see and measure. Take, for example, the ancient Greeks. Around the 4th century BCE, philosophers like Aristotle imagined the cosmos as a series of perfect, crystal spheres, each surrounding the Earth like delicate, transparent nesting dolls. Beyond all of these spheres, Earth, the planets, the fixed stars, Aristotle believed there might lie a realm called the primum mobile, the first mover, or perhaps even an ethereal boundary inscrutable to humans. For Aristotle and many who followed, the cosmos was finite. It had an edge, and beyond it, literal nothingness, a concept both satisfying and discomforting. Think now of the ancient Egyptians and Babylonians. The Egyptians, observing the daily reliable path of the sun, envisioned the sky as the body of a goddess arched protectively over the earth. The Babylonians, masterful astronomers for their time, were under no illusions that the stars were limitless. Rather, they tracked constellations moving within a vault, a solid dome rigged above us by the gods. Each civilization's model placed humanity at the center, encased safely, if not a little anxiously, inside a knowable bubble. Much the same was thought in ancient China, where some scholars pictured the heavens as a great turning sphere. These worldviews deeply influenced science for centuries. If you'd lived then, the cosmos might have felt vast but fundamentally enclosed, a decorated ceiling painted lavishly for our benefit alone. The sense of space wasn't endless, but reassuringly defined, structured by divine order or the logic of perfect shapes. Yet even in these early ideas, there were seeds of doubt and wonder. Pythagoras and later philosophers began to toy with the possibility of infinity, of things too boundless to grasp. Lucretius, a Roman poet and philosopher, wrote in the 1st century BCE of the boundless void, arguing that if you could sail to the edge of the universe and stretch out your hand, you'd either find yourself blocked by a wall or poking into even more emptiness. That boundlessness might be the only answer that makes sense. It's worth pausing to let this sink in. For hundreds, even thousands of years, the prevailing wisdom was that there must be an end to space. The universe was a cosmic house, exquisitely decorated, with walls beyond which was only nothing. But here and there, lone voices imagined otherwise, whispering that the edges might only be tricks of the mind, and that perhaps the adventure would go on and on, forever. Even now, as you rest and listen, the echoes of these ancient ideas remain with us. When you picture space ending, are you imagining a wall, a celestial curtain, or simply more and more darkness, fading into endless potential? There is comfort in boundaries, of course, but also an irresistible mystery in infinity. As we move through time, and as scientific tools grew sharper, humanity's view of the cosmos would shift dramatically. But here, in this gentle darkness, let yourself move back and forth between those ancient ideas, a universe safely wrapped, or a night sky more endless than our earliest minds could ever have imagined. Now let's gently trace the transformation that occurred when humanity realized the Earth itself was not the flat or stationary center of the universe, but a sphere drifting through space. For a long time, many cultures imagined their world nestled firmly in the middle of a flat cosmos, with clear boundaries separating above from below, Earth from sky, and us from the great unknown. It made sense. A horizon appears to rise up around us like a gentle bowl, and our everyday experience gives no hint of the planet's true geometry. But curiosity is as persistent as moonlight. As early as the 6th century BCE, Greek philosophers such as Pythagoras began to suspect the Earth might be round. Their reasoning was intricate yet practical. Ships disappearing hull first over the horizon, the curve of the Earth's shadow during lunar eclipses, and the changing positions of stars as one travelled north or south. By the time of Aristotle, in the 4th century BCE, the concept of a spherical Earth was embraced, even if the cosmos was still envisioned as finite and centered on us. Sail with me for a moment to the 3rd century BCE and meet Eratosthenes of Cyrene, whose work still echoes through classrooms and planetariums today. Using nothing more than a stick, a well, and a clear understanding of geometry, Eratosthenes measured the angle of the sun's rays in 2 different Egyptian cities at the same moment on the summer solstice. Noting the difference in shadow lengths between Syene, modern Aswan, and Alexandria, and knowing the distance between the cities, he calculated the Earth's circumference with surprising accuracy within just a few % of our modern understanding. His result was extraordinary for its time. The Earth was not only round, but immense. The ripple effect of this realization was profound. If the Earth was a globe, could other celestial objects be spheres too? Could the stars themselves stretch into space without simple, hard boundaries? The idea that our world might be one among many, a tiny planet balanced in a much greater night, quietly unsettled the imagination and began to sow questions about what, if anything, lay beyond. As centuries slipped by, more thinkers joined the conversation. The Indian astronomer Aryabhata wrote of a round Earth in 499 CE. And in the Islamic Golden Age, scholars like al-Biruni not only measured Earth's circumference, but speculated about the nature of the heavens beyond. Even in medieval Europe, where flat Earth myths have been greatly exaggerated in popular retellings, educated people by and large accepted the globe model. The realization that the Earth was round, a cosmic sphere rather than a cosmic raft, reshaped our place in the universe. Once it was established that planets moved, that Earth was just one of several, and that the heavens themselves might stretch much farther than the imagination could reach, the question, does space ever end, became richer, more complex, and even more mysterious. This knowledge did not instantly dissolve comforting boundaries, but it gently pushed the edges outward. Instead of a solid shell or ceiling, space began to shimmer with the suggestion of something boundless, a domain that perhaps would never yield its final wall to human discovery. The sky was no longer just a painted dome, but perhaps the opening to a much deeper, broader cosmic ocean, one that, as we'll see, scientists are still attempting to chart. As you relax and drift with this thread of history, notice how each step in understanding, from the curve of a planet to the curve of the cosmic horizon, pushes back the walls of the universe, both real and imagined. When you next step outside at night, know that you are standing on a sphere quietly spinning within a universe that may be even rounder, vaster, and more complex than any single stargazer first dreamed. Let us now float gently into the era when our understanding of space took its next leap, a time when the solar system itself was first unmoored from being the totality of everything, to just being the tiny neighborhood we occupy in a vastly greater universe. Picture, if you will, generations of astronomers and sky watchers. For centuries, the known planets, Mercury, Venus, Mars, Jupiter, and Saturn, were seen as roaming lights among the constellations, a handful of wanderers threading through a background of fixed stars. Beyond Saturn, it was easy to imagine. Surely, there must be a final shell, a last star, a celestial limit. But every advance in looking outward gently expanded our boundaries. When Galileo, in 1610, first turned his small telescope to the heavens, he expected clarity, but found instead a sea of surprises. The Milky Way, never more than a faint band to the naked eye, suddenly resolved into countless distant stars. The planets were not perfect lights, but worlds, showing phases and moons of their own. The more clearly we saw, the more vastness we discovered. Edmund Halley, in the late 1600s, argued that the universe must go far beyond our solar system, as new stars could be seen with larger telescopes, revealing a cosmos much deeper than the ancients could have known. Then, in the 18th and 19th centuries, astronomers like William and Caroline Herschel mapped clusters and nebulae, finding that the stars were scattered in complex, sprawling structures, not fixed to some inner ceiling of the universe, but floating within it. Gradually, the solar system shrank in our imagination. What was once believed to be the center and the edge of everything came to be understood as merely local, an address, not a border. By the time the 20th century dawned, some visionary astronomers even posited that the spiral nebulae observed in the telescopes, such as Andromeda, might not be little clouds within the Milky Way at all, but entire galaxies, island universes, of their own, separated by unimaginable distances. Let's pause for a moment and imagine this. From thinking we lived just under a shell of stars encasing a gentle planetary system, scientists began to realize that our sun itself was one of perhaps hundreds of billions just in the Milky Way. By the late 1800s, debate raged. Was our galaxy all there was, or simply one of countless others scattered through infinite darkness? This gradual shift from solar system to a galactic and then intergalactic sense of the universe left humanity both dwarfed by the scale and buoyed by the excitement of limitless possibility. It was thrilling and humbling at once, a powerful combination, and one that continues to echo in our gentle nighttime wanderings. For you, settling into the quiet, it means that the sky above is not the lid of a box at all, but merely a window. Our solar system is just a tiny home within an ever larger landscape, and every time we reach outward with our science, we find there is further still to go. It is a lesson both soothing and profound. New knowledge always expands the edges of what we know, leaving space endless, or at least endlessly mysterious, for all who come after. As our imaginations drift deeper, let's pause to truly appreciate the breathtaking scale of space. A scale so immense that our minds, tucked gently into the comfort of night, can only begin to grasp its magnitude with careful, soothing steps. The numbers involved are so enormous that we often need new metaphors, comparisons, and units just to discuss them. These cosmic distances are measured not in meters or miles, but in light years. The distance that light, the fastest thing in the universe, travels in 1 year. To put that in perspective, a single light year equals about 9.46 trillion kilometers, or roughly 5.88 trillion miles. A figure large enough that it can almost lull us with its incomprehensibility. Let's gently spiral outward from our home. Our own moon is just a whisper away in cosmic terms, about 384,000 kilometers, or roughly 239,000 miles, from Earth. You could drive there in a single year if you never stopped for rest, and yet, the nearest planet, Venus, at its closest, is over 40 million kilometers, 25 million miles from us. Our sun, which anchors our solar system and bathes life on Earth in light, is already 150 million kilometers away, a comfortable 8.5 minutes travel for a ray of sunlight. But the edges move further still. The outermost planet, Neptune, orbits about 4.5 billion kilometers from the Sun. Voyager 1, our most distant spacecraft, launched in 1977, has ventured beyond the solar system's boundary called the heliopause, more than 23 billion kilometers from home, still transmitting its faint, steady signal. Now, lift your perspective to the stars. The nearest star beyond our Sun, Proxima Centauri, shines dimly at a distance of 4.24 light-years away. That's over 40 trillion kilometers, a distance so enormous that, even traveling at the speed of today's spacecraft, it would take tens of thousands of years to reach it. Consider that the Milky Way itself, our galactic home, is a rotating disk of stars stretching more than 100,000 light-years from end to end, holding perhaps 200 billion stars, each with worlds of its own. The vastness continues. The Andromeda Galaxy, our neighboring island in the cosmic sea, is 2.5 million light-years away. And while that seems almost unimaginably far, it's just our next-door neighbor when you look at the tapestry of the entire observable universe, a sphere centered on us. Not because we are special, but because we can only see as far as light has had time to travel since the universe began. At last count, the observable universe spans about 93 billion light-years across, containing something like 2 trillion galaxies, each a swirling home for billions and billions of stars and perhaps even more planets. You might imagine pouring a single grain of sand onto a beach, then realizing that every grain on every beach on Earth doesn't even approach the number of stars scattered through these cosmic depths. It's a scale that can lull you into a relaxing sense of humility, making one's daily worries shrink down to almost nothing by comparison. But it also inspires a quiet awe, a reassurance that the cosmos is capacious enough to hold any dream or question you might conjure in these quiet hours. And yet, for all our greatest numbers, the question lingers: does it actually ever end? Or do our statistics only describe what we can see, not what there truly is? In the next gentle steps of our journey, we'll discover what scientists mean by the observable universe, and why, even as we offer such vast numbers, there is mystery layered deep within every light year. So, as you rest beneath this canopy of cosmic statistics, let your mind drift between scale and wonder. In the soft darkness, numbers become a kind of lullaby, measures of how far we've come in understanding, and reminders that the universe, in all its immensity, still keeps its final boundaries, if there are any, tenderly out of reach. Now, let your thoughts glide to a concept as central as it is wondrous: the observable universe. This is the term astronomers use to describe the largest region of the cosmos we can possibly see. Not because there are literal walls, but because the speed of light itself sets a gentle but absolute limit to how far our gaze can travel through space and backward in time. The observable universe isn't like a bubble we could ever reach or peer through. It is a sphere, about 46 billion light-years in radius, centered on you, wherever you are. The number sounds fantastical, but here's the logic. The universe is approximately 13.8 billion years old, so you might expect the maximum edge of visibility to be 13.8 billion light-years away. But because space itself has been stretching, expanding relentlessly since its birth, the most distant regions from which light has just managed to reach us have, themselves, moved even farther away in the interim. That's why the size of the observable universe is so much greater than the universe's age might first suggest. This region, this reachable sphere of information, contains everything from the smallest flicker of ancient galaxies to the afterglow of the Big Bang itself, the cosmic microwave background, a diffuse, nearly uniform bath of energy gently bathing the entire sky. Every star, every planet, every breathtaking phenomenon you've ever glimpsed through a telescope or in deep space, images is tucked comfortably within our observable boundary. Beyond it, though, lies silence. Not because there's nothing out there, but because its signals have not yet had time to reach us. There may well be entire expanses teeming with galaxies, with their own stories and secrets, forever hidden on the other side of our cosmic horizon. The beauty and comfort of this idea is that our observable universe is personal and unique to each observer. Imagine a friend, perhaps hundreds of millions of light-years away. If they were there, their observable universe would overlap with but not fully encompass ours, and their far horizon would be a slightly different slice of creation. In this gently shifting way, the limits to our cosmic vision are set not by a hard physical edge, but by the interplay of light and time, chance and position. What's beyond the observable universe? That is one of the great ongoing mysteries of science, and we'll explore it further as our journey continues. For now, It's soothing to know there are boundaries, not the forbidding kind you might meet with a thud, but the gentle hush of unreachable distances, set by the finite speed of light and the age of the cosmos. These natural limits enclose our cosmic experience like the sea's horizon encloses a solitary ship, offering as much comfort as curiosity. Rest in the knowledge that you are situated in a universe whose scale is both precisely mapped and deeply mysterious, whose boundaries are defined not by walls, but by the peaceful workings of physics themselves. The sky above you is not an end, but the beginning of a journey as vast as time allows, gently inviting you to follow its faintest signals as far into the night as imagination will carry. To understand the mysterious notion of the universe's edge, it gently helps to consider the role of light as our cosmic messenger and our greatest limitation. Light, moving at a swift 299,792 kilometers per second, or about 186,000 miles per second, is not only the fastest thing in the universe, but also the very thread that connects us to the farthest reaches of the cosmos. Every star you see in the night sky is not as it appears now, but as it was when its light first set out, sometimes decades, centuries, or even millions of years ago. You are peering quietly into the past with every upward glance. Consider the sunrise or the comforting familiar radiance of our sun during the day. That sunlight left the sun's surface roughly 8 minutes before it warmed your face or lit your bedroom curtains. If the sun were to vanish suddenly, not that it will, of course, it would take 8 minutes for earthbound eyes to know. In a similar way, every star shining above is a window into a different chapter of the universe's story, its light having traveled a unique and sometimes astonishing distance. Yet, light's breathtaking speed is still finite. That limit, so gentle and absolute, creates the soft boundary of what we can ever know. The light from galaxies billions of light years away began its journey before our planet, our sun, or even our solar system had formed. There are galaxies so incredibly distant that the light they emit now, set forth in our direction, will never reach us, simply because the space between us is expanding faster than light can travel across it. In this gentle contest between the speed of light and the restless stretching of space, a boundary emerges, soft and scientific, a horizon of what's possible to observe. Astronomers build their understanding of the cosmos with light as their guide. Telescopes gather ancient photons, those tiny packets of light energy, from all across the sky, assembling images that show not only where things are, but where and what they were long ago. By measuring the faint glow of distant galaxies, or by studying the relic radiation left over from the universe's earliest moments, we can reconstruct the cosmos's story, even as we know we're only ever seeing its painted past, not its absolute present. What about other messengers? Could particles or even gravitational waves someday show us beyond the regions light can reach? In principle, yes, but these signals too are bound by cosmic laws and distance. They offer fascinating new layers, but they cannot outpace the universe's speed limit. Thus, our cosmic horizon, the limit of what we can ever see or learn, remains gently set by light's patient, ceaseless journey. Let this scientific fact become almost comforting as you prepare for sleep. The universe is not teasing us with arbitrary limits, but rather offering us a quiet, logical boundary, one set by the fabric of physics itself. When you look up, the stars twinkle softly, each a patient traveler across aeons, their light brushing your eyes as the gentle proof that they, and the cosmos beyond, once existed in some other time, far, far away, and perhaps most soothing of all. While the light from many places may never reach us, the cosmos still shares its story, flicker by flicker, carrying its message across the vast, silent darkness until it whispers its way directly to you. Now, as we settle more deeply into our journey, let your mind drift to one of the most quietly transformative discoveries in human history. A revelation that changed both the way we see the stars and how we imagine our place within them. This is the story of Edwin Hubble, an American astronomer whose quiet tenacity in the early 20th century would reshape the boundaries of the universe itself. In the 1920s, Hubble worked at the Mount Wilson Observatory in California, perched high above the city lights with a telescope that, for its time, was the most powerful on Earth. Astronomers had just begun to debate a question that feels astonishing today: whether smudges and swirls known as spiral nebulae simply clouds in our Milky Way, or could they be entire galaxies far beyond, each a city of stars in its own right? Hubble set to work with the patience of a late-night dreamer. He hunched over glass photographic plates, looking for tiny points of light called Cepheid variable stars, which pulse in brightness at predictable rates. By measuring how bright these stars appeared and comparing them with their known intrinsic luminosity, Hubble could quietly calculate their distances. To his awe, and eventually to the astonishment of the world, Hubble found that the Andromeda Nebula was too far away to be within the Milky Way. It was its own galaxy, millions of light years beyond. This single realization burst open the cosmic borders that had seemed so stable for centuries. If Andromeda was an island universe, so too might be many other nebulae, scattered deep across the night. Our Milky Way, though still immense, was no longer the entire show, but one among billions. Hubble's quiet work did not stop there. As he catalogued more and more galaxies, he noticed a gentle but consistent trend. Almost all of them seemed to be moving away from us. The farther away a galaxy was, the faster it receded. This discovery, summarized as Hubble's law, showed for the first time that the universe itself was expanding. Space was not static, nor fixed by invisible walls or limits. Instead, it was dynamic, stretching in all directions, with every galaxy taking part in this grand, silent movement. The ramifications are profound. The stars you see tonight represent merely the tiniest sliver of what's out there, each one part of a galaxy, and each galaxy drifting away from almost every other, woven into the fabric of a universe getting bigger every moment. So, when you gaze upward, or simply imagine the vault of space from the comfort of your bed, know that you are cocooned within a galaxy, itself adrift in a sea of billions. So many that their combined light creates the faint silver band of the Milky Way across dark skies. Hubble's revelations invite us into a universe without a simple, sudden edge, but rather an ever-expanding vista, promising new wonders with every widening boundary. As your thoughts drift toward the boundaries of sleep, you can rest knowing the space above you is not just immensely vast, but beautifully rich with galaxies, each a silent participant in the cosmic dance first made visible to us by the careful whispering work of Edwin Hubble. Let us now gently explore the idea that space isn't merely a backdrop on which stars and galaxies are arranged, but a living, ever-changing fabric, a concept that lies at the heart of what astronomers mean when they speak of cosmic expansion. Imagine holding a delicate sheet of fabric between your hands, speckled with glittering points. If you slowly stretch the fabric outward, every speck moves away from every other, not by their own motion, but because the material supporting them is expanding. This is the universe as we understand it since the early 20th century, framed not by static emptiness, but by the expansion of space itself. After Hubble's discovery that nearly all galaxies are moving away from us and from each other, it became clear that something profound was at work. The further out you look, the faster galaxies recede. This isn't because the galaxies themselves are pushing through space, but because space itself is stretching, carrying galaxies along for the ride. Think of the famous raisin bread analogy. If you imagine dough rising in an oven, dotted throughout with raisins, you'll see that as the dough expands, Every raisin moves further away from every other raisin, not because they're traveling through the dough, but because the dough itself is getting bigger. Every point in the dough experiences expansion, and if you erase the outer crust, there would be no clear boundary, just the endless swelling of dough and distance. In our universe, it's space that swells, and the galaxies ride along. Every patch of air in your room, and every intergalactic void billions of light years away, is part of this grand, gentle expansion. This discovery traces its roots back to Einstein's general theory of relativity, published in 1915. A leap of understanding that described gravity not as a force acting at a distance, as Newton once thought, but as warps and bends in the very fabric of space and time themselves. When astronomer Georges Lemaitre, a Belgian priest and physicist, solved Einstein's equations in the late 1920s, he found that the universe need not be static. It could expand or contract, and the evidence pointed, ever so gently, to expansion. Einstein at first disliked the notion, but the mounting evidence from observations proved inescapable. The universe was growing, every second, everywhere at once. For you, this means that space is not a flat, undisturbed nothingness, but a dynamic stage, always changing underneath galaxies' feet, even when those galaxies appear perfectly still. The distance between galaxies grows not because anything travels faster than light, but because light's journey itself becomes longer as the fabric stretches out. This cosmic expansion is not noticeable on the scale of solar systems or even our Milky Way. The gravity of stars, planets, and galaxies holds them together tightly enough that the subtle swelling of space is overpowered by their local gravity. But across gigantic intergalactic distances, space's expansion quietly reigns, steadily increasing the distance between clusters of galaxies more and more with time. What about the edge? In this picture, there is no outer skin, no cosmic wall wrapping around all that exists. There is simply more space, stretching more, everywhere and at every moment. The concept of an edge becomes slippery, a word that loses its usual meaning against the cosmic tapestry. As you rest and contemplate the calm, silent expansion that is happening everywhere and all at once, know that you are woven into this process too. Every atom in your body, the very air you breathe, is part of this stretching fabric, tied to a universe that never stops unfolding itself, gently and ceaselessly, from the moment it began. As our journey floats yet deeper, we drift to a dawn immeasurably distant, the mysterious moment now called the Big Bang. This is not an explosion flinging fragments into empty space, as the name might suggest, but the birth of space and time itself. Before the Big Bang, there was no elsewhere, no endless darkness or great void for something to expand into. Space and time were not simply waiting for matter to fill them. They began together, woven from the same primordial moment. This idea, gently radical though it may sound, is supported by astonishing layers of evidence. The cosmic microwave background, for instance, is a faint, cool afterglow visible in every direction, a relic heat signature from a time just 380,000 years after this beginning, when the universe cooled enough for light to travel freely. This gentle, uniform radiation tells us that the universe once existed in a state both very hot and very dense, and it has been cooling and expanding ever since, the glow thinning and softening as eons pass by. In the tapestry of scientific history, you find names like Georges Lemaitre, who first proposed the idea of the primeval atom in the 1920s, and George Gamow, who in the mid-20th century predicted the cosmic background radiation. Arno Penzias and Robert Wilson, working at Bell Labs in the 1960s, measured a faint noise in their radio receiver that turned out to be the first direct evidence of the Big Bang's lingering warmth, awarded the Nobel Prize for a serendipitous but world-changing discovery. What, gently, does this mean for our question about the edge of space? It means that asking what lies outside the universe is a little like asking what's north of the North Pole. There simply is no outside, no further expanse beyond the universe's birth. For the Big Bang created not just all matter and energy, but the very theatre, space and time in which all plays take place. The beginning, in this view, was not a fireball expanding into vastness, but the creation of vastness itself. Consider now the flow of time. Every second that slips quietly by draws you further away from that origin, but you remain woven into its fabric. Your own atoms once fused from the ancient light and heat of the early universe. Still, the question remains for scientists and philosophers alike. If the universe began at a moment in time, could there be something beyond, some other reality or hidden backdrop? Most scientific evidence suggests our universe contains all that is, with space and time curving back into themselves without any outside region, at least as far as our mathematics and experiments reveal. So, as you ponder the edges of space while the world around you softens into darkness, think of the Big Bang not as an explosion you might witness from afar, but as the grand beginning of all things familiar and possible. Its echo, traced in the hush of the cosmic background, offers quiet assurance. The universe's story has a starting point, but not in the familiar sense of an edge. For the beginning was not a border, but the first gentle unfolding of space, time, and possibility. Allow this understanding to ease gently over you, drawing a thread from your present moment, through the whole of cosmic history, back to the moment when space itself began to expand. And remember, this process of discovery itself has no edge. With the understanding that the Big Bang marks a beginning to space and time, we are now invited to wonder, quietly, reverently, what lies beyond our horizon. When we speak of horizons, we do not mean a visible edge like the end of an ocean, or the line where sky meets land. Rather, our cosmic horizon is defined by the farthest reaches from which light, traveling since the birth of the universe, has managed to arrive at Earth. This is why the observable universe is a sphere around us, stretching about 46 billion light-years in every direction, not a physical boundary, but the limit set by time and the gentle speed of light. What then lies beyond? Astronomers conclude, with a soothing confidence based on observation and theory, that the universe itself does not cease at this horizon. Instead, most models suggest that space continues smoothly outward, a vastness larger and perhaps infinitely larger than the slice we are able to see. If you could somehow soar at impossible speeds across that boundary, you would likely find yourself gliding through yet more northern galaxies, star clusters, and cosmic wonders, each woven from the same rules and building blocks that shape our own cosmic neighborhood. There is a lovely symmetry in this arrangement. The cosmic horizon is not unique to you, but personal to every observer throughout the cosmos. An astronomer witnessing the universe from a distant galaxy would see their own observable sphere, overlapping with ours, but subtly shifted, exploring depths we cannot access, while missing parts only we can see. The universe, from each vantage, is centered upon the observer, not by arrogance or design, but simply because distance and time enforce a gentle relativity to what can be witnessed. There are regions forever hidden from our awareness, places whose ancient light will never reach us, not because they lie outside the universe, but because they dwell beyond this softly receding edge of knowability. Scientific reasoning supports the notion that, outside our observable universe, conditions are likely much the same. Matter, energy, and the gentle laws of physics repeating beyond reach. Cosmologists sometimes refer to this as the unobservable universe, the domain just as real as ours, yet eternally veiled. The total size of the universe, then, could be vastly greater than anything we will ever map or chart, and perhaps even truly infinite. Here, scientific humility is both necessary and soothing. No telescope, however powerful, can show us what lies far beyond the horizon of light, set by history and expansion. Yet the vastness is not empty, but filled with the promise that the universe is always more generous than what we can simply measure. Every patch of night sky, however small, gazes toward depths that will never fully be revealed. This gently hidden beyond, the more that always lies just outside our grasp, is not a failing or limit of human understanding, but a permanent feature of the cosmic story. The universe patiently withholds some of its secrets, asking us to accept that our place in space is both immensely small and, paradoxically, always at the center of our own observable sphere. So, as you drift, in mind and body, allow yourself comfort in the knowledge that the cosmos likely stretches on endlessly beyond every horizon. The universe does not end where our sight fails, any more than the world ends beyond a distant mountain ridge. The realms beyond our reach are as real and as quietly wondrous as the patch of sky above you now. As you relax deeper into this question, does space ever really end? It's natural to encounter the idea of infinity, a concept with a soothing, even mysterious flavor in both mathematics and philosophy. Infinity is a word we whisper when we imagine something stretching on forever, with no boundaries, no last step or wall. But does the physical universe truly possess this quality? Or is infinity just a useful idea, a way to express something vastly, vastly large? In mathematics, infinity has a precise identity. Numbers can grow without bound in an endless sequence, and the continuum of possible points on a line can be infinite. Infinity is a powerful tool in scientific thought, helping physicists make calculations, design theories, and even distinguish between the possible and the impossible. But when we carefully turn to nature, what our senses and experiments reveal, the question becomes gently nuanced. Is there anywhere in the universe something literally infinite? A distance, a quantity, a region with no boundary at all? Most cosmologists tread softly here. The observable universe, as we have discovered together, is undeniably vast but measurable. It holds a finite number of galaxies, a countable, if enormous, collection of stars and planets, all wrapped within that sacred horizon set by the age of light. Yet many mathematical models of the universe, such as those assuming flatness at cosmic scales, suggest that space might indeed be infinite, stretching endlessly in all directions, with no ultimate wall or returning loop. If this is true, then beyond our observable patch, the universe would simply go on and on, every region as real and rich as what we see now. But scientific humility steps in again. We cannot test infinity directly. We can only infer, based on the geometry we observe and the uniformity of the cosmos, that endlessness is possible, or perhaps even likely. Consider now how differently infinity feels in pure mathematics versus in the physical world. In math, infinity contains endless variety, a never-complete story. In physics, though, infinity can sometimes signal a gap in our understanding, a place where our equations blow up and logic breaks down. Cosmic singularities, like those at the centers of black holes, or at the very instant of the Big Bang, may mark not physical infinities, but moments where our current laws reach their limit. There is also a gentle comfort in the ambiguity. Even if the universe is not truly infinite, its scale is so huge as to be, for all practical purposes, endless. If space is finite but unbounded, like the surface of a sphere, only in more dimensions, it still has no edge, no last place or final frontier, only gentle loops and curves that could bring a traveler back to their starting point without ever crossing a cosmic boundary. So tonight, as infinite and restful darkness surrounds you, know that science treats infinity both as a tool and a mystery. When we ask, does space ever end? We peer into a chasm where philosophy and physics blend, where the universe may be finite or endless, and where our curiosity itself is a small, comforting kind of infinity, always reaching for what lies just beyond. As our journey unfolds through the soft hush of night, let's imagine the possible shapes that the entire universe might take. Shapes that, according to modern cosmology, tell us crucially whether space ends, loops, or stretches forever. Scientists have discovered that the fabric of the cosmos can, in theory, assume one of three broad geometrical forms. It can be closed like a sphere, open like a saddle, or flat like an endless sheet. Each form carries gentle, far-reaching implications for the fate and boundaries of everything we know. The first possibility is a closed universe. To picture this, imagine the surface of a globe, finite in area, yet with no edge, so you could walk in any direction indefinitely and always eventually circle back to your starting point. In this model, space has a positive curvature. If you set off in a perfectly straight line, carried magically through the void, you might, over timescales longer than eons, end up right back where you started. There's no wall, no abrupt drop-off, just a gentle cosmic roundness echoing the closed surface of Earth. If our universe is closed in this way, its total size is vast but finite, and someday the expansion might reverse, ending in a big crunch where everything collapses inward again. The second shape is an open universe with negative curvature, akin to the surface of a saddle or a Pringle chip. In this scenario, space would stretch outward forever, each point curving away from every other. Travel in a straight line, and you'd never return to your origin. The cosmos would be infinite in extent, destined to keep growing colder and emptier without cyclical return. And then, gently balanced between these options, is the flat universe, a cosmos with zero curvature, perfectly poised between closing back on itself and opening infinitely. Here, the geometry is like an infinite sheet, with parallel lines staying parallel forever. A flat universe, if truly infinite, would have no edge or wall. If flat but finite, it could still wrap around in subtle ways, allowing a traveler's path to repeat without boundaries. So, what does the evidence suggest? Using exquisitely sensitive measurements, particularly of the cosmic microwave background, astronomers have found the universe is astonishingly flat, at least to the limits of our measuring ability. Data from NASA's WMAP satellite in 2001, and later the Planck spacecraft in 2013, hint at a universe whose geometry is so perfectly flat that, within tiny margins, it could well be infinite. Yet, even here, mystery persists. Tiny uncertainties leave open the door to either a very large closed universe or one that truly runs on forever. If the universe is flat and infinite, it never ends. If subtly closed, it gently loops without ever presenting an edge, the way a horizon always recedes from view. As you relax deeper, picture the cosmos shaped not by hard limits, but by the subtlest curves, a geometry revealed by ancient light and gentle mathematics. In the question of shape lies also the question of destiny. A closed universe might cycle back. An open or flat one could expand forever, ever softening, ever reaching for new horizons. Tonight, let your mind trace these possible shapes in the dazzle of distant stars. The universe, in its grandest form, is a quietly balanced architecture. Its fate and the existence of an end, revealed not by walls, but by the endless, soothing possibility of shape. Now let us gently venture into one of the most quietly thrilling ideas to ripple through modern cosmology: the notion that our universe might be only one among multitudes. Multiverse theories, though speculative and built on the edge of current understanding, offer an expansive, imaginative view that makes the question, does space ever end, both richer and more mysterious? The multiverse hypothesis emerges from several clues in physics. Some appear in the mathematics of cosmic inflation, the brief, breathtaking expansion that occurred fractions of a second after the Big Bang. According to the work of physicists like Alan Guth and Andrei Linde in the 1980s, inflation could make pocket universes or bubble universes form within an ever-expanding, frothy cosmic field. Each pocket would have its own laws of physics, its own version of space and time, and perhaps, most intriguing of all, its own boundary of the observable. Our universe, then, might simply be one bubble in a vast, possibly infinite multiverse sea. Other hints arise from string theory, the still unproven but mathematically rich attempt to unite quantum physics and gravity. String theory does not just require our familiar 3 spatial dimensions, but 9 or even more, some tightly curled and hidden. In some models, these extra dimensions allow for an endless variety of universe types, each with distinctive physical constants, particle masses, and strengths of force. There's also the many worlds interpretation from quantum mechanics, a gentler but no less radical suggestion. In this view, every possible outcome of every quantum event actually occurs, creating a vast branching tree of realities. Countless variations of you might exist, each only slightly different, scattered across parallel quantum branches. Importantly, these ideas, though rooted in mathematical logic and emerging from gaps in our current theories, remain beyond direct observational reach for now. The light from another universe, should such a place exist, can never arrive. There are no telescopes that can peek through the walls of a cosmic bubble. The multiverse remains a deeply theoretical concept, one that stretches human curiosity to its outermost edge. Still, the multiverse provides a soothing, humbling answer to our nightly question. If universes themselves can multiply and sprawl without end, then the concept of a final edge fades away almost entirely. What appears to be the boundary of everything might just be the threshold between one cosmic bubble and the next. For now, you can rest in the poetic comfort that science moves gently from wonder to hypothesis, from hypothesis to proof, and sometimes, lovingly, back again. The idea of the multiverse keeps alive the possibility that what we know is only a sliver of all that can possibly exist. So as you drift through the darkness, let your mind expand into realms upon realms, possibly infinite, each with its own stars, planets, and dusk-lit questions. The multiverse invites us to imagine that the answer to "does space ever end?" might be not just no, but no, not even close. Each universe soft as a ripple upon a boundless sea, with the concept of the multiverse resting gently like a thought on the edge of a dream. Let's return to the idea of our universe's own expansion, and how, with every passing moment, more space itself is being created. This idea can feel slippery at first, like trying to grasp the quiet movement of midnight air, yet it holds the key to what edge truly means in cosmology. Cosmic expansion, as first described by Edwin Hubble and rooted in Einstein's equations, is not about matter rushing outward into a waiting emptiness. Rather, it is space itself, the very distance between 2 points, even those unimaginably far apart, steadily stretching like an endless softening taffy. The galaxies hurry away from us, not because they're moving through space, but because new space is constantly unfolding between every pair of galaxies not gravitationally bound to each other. What does it mean, then, to say that new space is created? Imagine dots on the surface of a balloon. As you inflate the balloon, the surface expands everywhere at once. There is no special edge where the new material must be added. In our three-dimensional universe, this analogy becomes even more profound. Every region, no matter how remote, is seeing the fabric surrounding it expand. There's no center, no outer skin, just endless, smoothly increasing distances. This ongoing creation of space means that talking about a boundary, about reaching the end, becomes misunderstood. There is no edge to bump into, and no external space that our universe expands into. The expansion happens everywhere, with every patch of cosmic ground softly stretching beneath galaxies and clusters, separating them from their neighbors. Take a moment and realize, too, the subtle distinction in cosmology between infinite and unbounded. The universe may be spatially infinite, or it may merely be so vast and smoothly wrapped upon itself that it is for all practical experience unbounded. A traveler can wander forever without ever encountering an edge, circling back by degrees in a cosmic loop. With the discovery of dark energy, the mysterious force accelerating the universe's expansion, announced in 1998, astronomers realized that this process isn't slowing, as once thought, but is speeding up. This means even more space is being gently spun into existence with every heartbeat. Distant galaxies, once visible, will drift away until the light they emit can no longer reach us, lost beyond a horizon formed not by a wall, but by the quiet, relentless growth of space itself. This understanding is both humbling and comforting. You are woven into a universe always quietly in motion, your atoms and your dreams carried outward on a cosmic tide that never stops flowing. There's no edge to reach, no final place where everything simply stops. There is only the ceaseless, gentle accumulation of space, everywhere and always, now and for all the nights to come. As you rest, imagine space blossoming with every moment, quietly expanding in all directions, bearing galaxies farther apart in a calm, cosmic waltz. The question, does space ever end, softens into a sort of lullaby. There is no edge, only more night, silently unfolding, more distance spun anew with each passing second. Let us now soothe our minds with a reassuring truth from the heart of modern physics. According to the best understanding science offers, you will never encounter an edge in space, no matter how far or how fast you travel. This is not for lack of trying or imagining, but simply because, as we have discovered, the universe is structured without a final wall, a border, or a place where all simply stops. The cosmos redefines edge, turning the idea from a literal boundary into something quietly, beautifully abstract. Picture yourself as an adventurous traveler, equipped with infinite stamina and time, setting off in a perfectly straight line. It does not matter which direction you choose, or how diligently you press onward. There will never come a moment when you slam into the end of all things. Instead, if our universe is spatially infinite, you would simply travel forever, the stars and galaxies thinning, but never entirely ceasing. If the universe is closed and unbounded, like the three-dimensional equivalent of the surface of a sphere, your endless journey would quietly, gently bring you full circle, right back to where you began, though you would never cross a wall, never notice a corner turned. This feature is rooted in geometry and the physics of space-time itself. Unlike an island or a room, space does not sit in some larger sea or chamber. It is all there is, its boundaries defined not by external markers, but by the logic of Einstein's equations and the intricate three-dimensional topology of space-time. The edges we encounter are only those of perception, the horizon set by the finite speed of light, or the veil created as expansion whisks distant galaxies beyond our reach. One gentle detail is often overlooked. Even if you traveled with technology that allowed you to surf the very fabric of space at the speed of light, you could never traverse it all. The universe is expanding so rapidly on its largest scales that there are regions whose light will never reach us, and which we can never reach in return, no matter how intrepid we become. The expansion creates a receding horizon, not an abrupt end. For centuries, stories and legends imagined falling from the edge of the world or peering over the cosmic brink into nothingness. Science replaces those fears with a delicate calm. There is no abyss to tumble into, no curtain to pull back. Instead, there is only the peaceful continuation of space and possibility. everywhere and always. As you settle into sleep, know that your place in the cosmos is utterly unique and absolutely safe. The Earth beneath you spins serenely within space, and all above you is a vast openness with no precipice, no wall, just the soft glow of distances that stretch farther than any dream. You cannot fall off the end of the universe, for the universe, shaped by the laws of nature, is made in such a way that there is always more beyond, or, if it is curved, simply a gentle return to where you began. Let every edge in your mind fade now, replaced by a soothing sense of boundlessness, the assurance that whatever questions you send outward will find only more cosmos awaiting, patient and endless, in the silent night. As our exploration sails even more softly onward, let us now pause to appreciate the curious, profound difference between an edge, as we usually imagine it, a sharp line, a dividing wall, and what an edge might mean in the language of cosmologists. In our everyday world, boundaries are blunt and physical. The wall at the end of a hallway, the shore where land gives way to water, the final page of a cherished book. Your senses are attuned to recognizing limits, a skill needed for safe passage through the tactile world. But in the universe, the notion of an edge turns elusive. The universe does not end abruptly. There is no cosmic equivalent of a brick wall, no shimmering barrier hanging at the edge of a starfield, no halt sign floating in the void. Rather, cosmic edges are set by the fabric of physics and the subtle workings of geometry. One way to picture this is through the concept of being in a finite yet unbounded space. Imagine the surface of a globe. As you walk, you never fall off an edge, but the space loops smoothly. There are no end markers or corners, just continuous travel. Some cosmologists suggest that space itself could be like this in 3 dimensions. If the universe is closed, a traveler heading in a straight line would eventually return to their starting point, without ever crossing an external boundary. There are also boundaries imposed not by physical structure, but by our capacity to see and experience. The boundary of the observable universe is set not by a wall, but by time and light. The cosmic microwave background limits how far back we can see, acting as a gentle fog from the earliest epoch of the universe, but not a final screen. There are regions eternally beyond our horizon, not by the universe's geometry alone, but because light from those places will never have time to reach us due to ongoing expansion. The universe's edges, in this view, are less like fences and more like horizons at sea, always retreating as you move toward them, promising more beyond, but never presenting a final terminus. Every observer, wherever they are, stands at the center of their observable universe, surrounded not by limits but by possibilities. This redefinition of edge is more than a technicality. It transforms how we relate to the cosmos. The universe doesn't trap us inside a box or tempt us with the prospect of falling away. Rather, it invites us to wander, to wonder, always finding new mystery as we move farther outward. Science does not cling to the language of boundaries in the ordinary sense, but prefers to speak in terms of topology, curvature, and the comforting soft barriers of information and time. There are no walls for you to hit, just the loving limit of what can be experienced, measured, or known from your place in space. As you let these gentle concepts ease into your thoughts tonight, you can let go of any fear of finality. The cosmic boundaries are of a different kind, not restrictive, but softly inviting, always hinting at more to discover, even as they comfort us with the sense that the journey of learning and imagination might never truly end. As the night deepens and your thoughts drift further, let us softly ponder not just where the universe currently is, but where it is going. A question that quietly reframes what end might mean on the grandest of scales. In cosmology, this is the study of the universe's fate. Will all of cosmic history flow gently toward endless expansion, collapse back into itself, or freeze in an eternal twilight? For most of modern history, scientists debated only 2 main scenarios. In one, Gravity, the gentle pull exerted by every bit of matter and energy, might eventually halt the universe's expansion. If this occurred, all the galaxies and stars would begin slowly drifting back together in a dramatic reversal, culminating in a big crunch. Every atom collapsing into a hot, dense state, reminiscent of the conditions at the Big Bang. In this vision, the universe would have a cyclical heart, oscillating between expansion and contraction, with no boundary but a repeating cosmic rhythm. The other scenario was the open universe, in which the universe possesses too little mass and energy for gravity to ever overcome the momentum of the initial expansion. If this is true, the cosmos will gradually thin out, galaxies drifting ever farther apart, light stretching to invisibility, temperatures falling lower and lower, in a scenario sometimes called heat death. The stars will one day burn out, and black holes will slowly evaporate. Even the smallest quantum fluctuations will fade, leaving a universe quietly cold and empty, a far-off future sometimes called the Big Freeze. A dramatic change swept in with the discovery of dark energy in the late 1990s. Astronomers, observing distant supernovae, found the universe's expansion is not just persisting, but accelerating. This cosmic acceleration means not only will distant realms move forever out of reach, but the gulf between galaxies will grow wider and wider, limiting the exchange of light, matter, and information on a grand scale. Some physicists speculate about even wilder fates, such as the Big Rip, in which acceleration increases so dramatically that, in unfathomably distant epochs, galaxies, stars, planets, and even atoms themselves are ultimately torn apart by relentless expansion. Other theories propose gentle endings, infinitely slow dispersal, quiet decay, endless simmering on the edge of total calm. Each potential fate, though different, shares one quality. There is no abrupt physical edge, no final cosmic wall. Instead, there are only changes in state and possibility. The universe changes, but it does not suddenly cease or drop away. The edges of existence in this view are the limits of what can happen, not borders to what is. This ultimate gentleness in the universe's destiny allows you, as you drift through the night, to relax into the certainty that whatever the eventual end, crunch, freeze, or slow attenuation, it will happen not in a place, but in a time, and not as a wall, but as a graceful transformation. Let this soften your questions as sleep nears. The universe's future is immense. The timescales so vast they become almost timeless. There are no precipices ahead, only cosmic seasons, changing softly and forever. Now, as our journey carries us to the very boundary of scientific knowledge, let's gently wonder about the frontiers that lie truly beyond, places not just unreachable physically, but perhaps woven from forms of space and energy our minds can barely begin to picture. Here, cosmology moves from the realm of confident equations and observation into the soft shimmer of hypothesis, where even the notion of an edge takes on new, tantalizing meanings. Current theories, informed by both quantum mechanics and general relativity, suggest the fabric of space-time itself might behave in ways more subtle and strange than classical physics ever dreamed. On the smallest possible scales, much tinier than atoms or even protons, space may not be infinitely smooth, but jittery and frothy, a turbulent quantum foam. In this domain, the very idea of distance blurs, and conventional geometry is replaced by an ever-bubbling sea of uncertainty, a place where time and separation briefly lose their hold. As scientists grapple with the paradoxes of black holes and the birth of our universe, they encounter limits to knowledge, horizons set not by light or expansion, but by the nature of information itself. For example, at the edge of a black hole lies an event horizon. Any information or light that crosses this barrier is lost to the wider universe. Its fate, a puzzle that blends questions of space, entropy, and time. These cosmic horizons share a kinship with the boundaries we find at the edge of the observable universe. but they are rooted in compact, extraordinary objects rather than the entirety of space-time. Meanwhile, some ambitious theories propose that our three-dimensional universe might be only a brane, a kind of membrane floating in a higher dimensional bulk. In these scenarios, arising from string theory and related ideas, our entire cosmic fabric is just one layer among many, with extra dimensions curled up, hidden from daily experience, but real and possibly infinite in their own rich structures. In these speculative realms, the word edge becomes almost poetic. The edge of space might mean the end of the physics we know and the start of rules we have not yet glimpsed. Or perhaps it means a transition between dimensions or universes. Perhaps there are domains where space and time behave differently, where what we call end is nothing more than the limit of our mathematics and imagination. And yet, even as we reach toward these unknowns, the methods of science remain gentle and reassuring. Every new theory must be tested, measured against the world as it is, its predictions confirmed by the patient gathering of evidence. Much remains mysterious, but with each generation, the cosmic edges are pushed gently outward, not by eroding what is unknown, but by expanding what is possible to ask. As you rest in the embrace of this gentle uncertainty, let yourself drift through all the layers, quantum foam and black hole boundaries, hidden dimensions and mathematical frontiers. The most profound edges are those of thought and discovery, places where curiosity thrives, where even a simple question like, "Does space ever end?" keeps leading science into ever more beautiful and surprising new dawns. Tonight, tuck yourself quietly into the comfort that while the cosmic unknown is infinite, so too is the slow, calm embrace of discovery. As we return gently from the wildest reaches of theory, let us turn inward and find our sense of place within the universe, because even in the vastness of all that exists, you carry a special connection to the cosmos, written deep into your very being. Sometimes, seeing the endlessness of space can feel overwhelming, a quiet sense of smallness, a breath of insignificance. But the truth is both more personal and more comforting. The stuff of stars and galaxies is the very matter composing you. Consider that every atom in your body, oxygen in your lungs, calcium in your bones, iron flowing through your blood, was forged long ago in the heart of an ancient star. When those stars exhausted their fuel, they spilled their rich elements into the galaxy, seeding dust and gas clouds with the material for future worlds, and for you. The water you drink may contain hydrogen set free in the first moments after the Big Bang, while the carbon in every breath comes from the silent work of stars aging and dying in distant centuries. Yet your cosmic identity is written not just in elements, but in your relationship to the fabric of space itself. As you move through your day and night, you are not sitting still in a finite room, but gliding gently through a universe that, on its grandest scales, is still quietly expanding. The distances between galaxies are growing, and though you cannot feel this in your skin or bones, the imprint is everywhere, a subtle, ongoing dance in which you are an unconscious partner. Many scientists find a gentle peace in this reality. You are small compared to the entire universe, but you are not separate or alone. The processes that shape black holes, create galaxies, and fuel the birth of stars play out on a microscopic scale in every cell and atom of your body. You are, quite literally, the cosmos made conscious, the universe reflecting on itself and gently asking through your every question, does space ever end? Even the air that fills your lungs once passed through countless other living beings, across centuries and continents, before finding its way to you tonight. And the photons, those little bits of starlight that land upon your pillow or dance upon your closed eyelids as you drift into sleep, have travelled unfathomable distances to share their quiet warmth. Allow yourself to rest in the knowledge that your existence is as natural and as spectacular as any supernova, any galaxy, any corner of the night sky. The scale of the cosmos can feel humbling, but it also brings a gentle perspective, a kind of cosmic embrace, a reminder that you have a place here, honored and inseparable from the universe's unfolding story. So, as your thoughts soften, know that asking great questions, even in the hush of night, connects you more deeply to the stars above and the atoms within, each echoing a quiet truth. You are, and always have been, a unique part of the universe's endless journey. Now let time quietly slow as you embrace not just the scale of space, but also the comfort found in the infinite mystery it holds. There is a gentle solace in knowing that some questions, like does space ever end, remain open, patiently waiting across generations. Science, for all its tremendous progress, does not always provide final answers. Instead, it offers a calm invitation to linger within curiosity, to gaze at the sky, and allow the unknown to be both humbling and soothing. Unlike the sharp worry of unfinished business, scientific mysteries cradle us in a sense of possibility. The vast openness of space need not be overwhelming, but can become a source of perspective and tranquility. When you settle under a swirl of stars, you sense the scale of the cosmos not just as something out there, but as a gentle challenge to the boundaries of your own wonder. Every stretch of darkness between stars is a field into which your imagination may roam freely, borne along by gentle questions rather than bracing answers. The universe's mystery is, in a way, endlessly nurturing. As astronomer Carl Sagan so often whispered, somewhere, something incredible is waiting to be known. The pursuit of the unknown is not about conquering or possessing the universe, but about building a lifelong relationship with curiosity itself. To know that there is more to learn, more to discover, and always more sky left unexplored is a resting place for the mind as much as for science. Consider how many generations have wondered about the cosmos, early stargazers drawing constellations, mathematicians sketching out infinite lines, children and elders alike soothing themselves with stories passed through time. The fact that you wonder here and now ties you to every human who ever watched the stars in darkness, who wondered softly if there might be something more. There is an ancient comfort in not knowing everything. The boundaries of scientific knowledge shift, yet always behind them lingers an infinite, peaceful darkness, a promise that mystery endures. The night sky becomes not a reminder of all you do not know, but a canvas wide enough to hold all your questions and imaginings, now and forever. So as your eyelids grow heavy and your breath deepens, let yourself rest in the arms of mystery. Questions are not obstacles in sleep or in science, but companions, gently guiding you from this moment into dreams where even infinity is possible. Now, beneath the soothing weight of nighttime silence, let's contemplate the simple peace that comes from spending even a single evening under endless skies. Throughout history, people everywhere have experienced the gentle comfort of sitting beneath the stars, letting their eyes and thoughts drift upward, untethered by the boundaries of walls or worries. The universe above may be vast and unknowable, but in these moments it asks nothing from you except presence. A quiet awareness that you are here, beneath its expanse, as generations before you have been. Contemplating the immeasurable depths of space can be paradoxically a source of calm. Just as the rhythmic sound of waves or the steady beating of your own heart helps anchor you, the infinite reach of the stars reminds you that life's daily concerns are small, fleeting ripples in a far greater ocean. When you lie back, whether on a gentle hillside, a rooftop, or even just beneath the imagined sky painted across your ceiling, the darkness above does not press in with dread, but opens outward in all directions, inviting restfulness and dreams. Astronomers sometimes speak of dark skies as precious and fragile, but you carry the memory of the infinite within yourself, even if city lights or weather obscure the heavens. Each night, when you close your eyes, you can summon the image of a sky dotted with stars. Each pinprick a sun perhaps surrounded by planets. Each patch of darkness a promise that something remains to be discovered. The experience of timelessness, of measureless, edgeless wonder, becomes a soft place to set your burdens down. There is also a gentle generosity in the knowledge that, in the same way the universe never presents an edge or a wall, your experience of night and sleep need not have a harsh boundary either. Thoughts can linger and fade, worries can dissolve into vastness, and what remains is the hush of possibility, room for new dreams and new questions, forever circling back without ever reaching an end. Take comfort in the idea that feeling small before the universe is not a defeat, but an invitation to humility, to perspective, and to a profound peace that comes only when you realize you are always part of something wonderfully unfinished. Your story and the story of the stars have always been intertwined, bound together in the soft arc of time and curiosity. So as you settle under whatever sky is yours tonight, know that you are in good company, sharing in a tradition as ancient as wonder itself. There is no need to reach for final answers, only to recline, breathe deeply, and let the quiet vastness of space and all its unending edges carry you gently to sleep. Let us now, in these final gentle moments of our cosmic journey, softly gather together the understanding we've gained. The question, does space ever end, has guided us not towards simple answers, but into a patient appreciation of mystery, a place where science and wonder blend as seamlessly as night melts into dawn. We've discovered that the universe, as best science can measure, stretches farther than any boundary our eyes can see, governed by the expansion of space and the calm logic of its own natural laws. We've learned that ancient worldviews provided comfort in the idea of defined edges, yet every advance in knowledge slowly pushed the boundaries outward, from Earth's horizon to a solar system to a galaxy, and then to a universe whose scale is almost beyond imagination. With each new discovery, the edge became larger, softer, less a wall and more a horizon, moving further as we grew capable of asking bolder questions. We traced how light sets the ultimate limits to what we can see, forming a sphere of observability that is personal and unique, yet also only one perspective among countless others scattered across space. We found calm reassurance in the fact that, under the current understanding of physics, there can be no final wall, no fall into an abyss, but only the gentle, never-quite arrival at a shifting, expanding edge. We pondered cosmic shapes, unending loops, hidden dimensions, and even the possibility that our entire universe is but one among many. We glimpsed frontiers where the language of space and time gives way to mathematical uncertainty and quantum fuzz, and we rested in the knowledge that wherever the true end may lie, it is likely a question of perspective, not of brick and mortar, a horizon, not a barricade. Most deeply, we return to the soft truth that you, a brief flare of thought and life in this vastness, are woven from the same fabric as stars, galaxies, even the dark that stretches between. The ultimate comfort isn't in knowing or not knowing the answer to where the space ends, but in embracing the awe and curiosity it inspires in you. This awe binds you to every human traveler who has gazed at the sky and wondered, reaching for meaning in the quiet. So as you close your eyes tonight, let this gentle summary linger. Space may be endless, or may gently loop beyond view, but mystery itself is not a flaw to be solved. It is a blessing, a companion, and the best invitation science can offer to dream. And so, as we come to the end of our gentle journey, let yourself rest in the peaceful embrace of all we've shared. We have traveled together from the innocent wonder of childhood, stargazing through the revelations of ancient philosophers and the breakthroughs of modern astronomy. Each step moving us further into a universe that is, at once, vast beyond measure and intimately connected to who you are. We've explored spheres and galaxies, cosmic expansion, the birth of space and time at the Big Bang, the farthest fringes illuminated only by the speed of light, and the deep possibility that space has no edge at all, only more gentle mystery spread forever onward. Feel the stillness that comes from understanding, if only for tonight, that some questions, like, does space ever end, can be a blessing, not a puzzle. You are a participant in the great cosmic story, a momentary thought in the long night of the universe, and that is a truth both humbling and comforting. As you drift closer to sleep, remember that every answer science gives leads to a new horizon, a new edge, never harsh, always receding with your curiosity, nourishing each night's dream. I'd still love to know where in the world you're watching from and what time it is there. Sharing the moment across time zones and continents is its own silent reminder of the endlessness that connects us all. Tonight, let your last waking thought rest softly on the realization that you are as much a part of the universe's infinite story as any star shining above. May your sleep be as gentle as the cosmic expansion, your dreams as boundless as space itself, and your spirit always soothed by the wonders that lie quietly, just beyond every horizon you can see. Let the cradle of the universe gently rock you into the calmest of nights, whispering, as only science can, that the end of space is not a wall, but a lullaby with no final verse, one you may carry with you, forever and always, into dreams.